You were probably wondering why that flash went off. Well, that was due to a resistor capacitor circuit. In other words, a circuit with a resistor and a capacitor in it. What you see here is we have a circuit that contains those items. We have a battery, we have a bulb, we have two switches, and we have a green capacitor on the right hand side, and a voltmeter to see if the capacitor is charging. At this point here, we will talk about the circuit itself. You'll note that we have two loops essentially. We have on the right hand side we have a battery, a switch, and a capacitor, and that's how we're going to charge the capacitor. And then on the left hand side we're going to have a bulb and a switch. Here's an animation of how the capacitor is charged. Currently we have a 1.5 volt potential difference across the battery. The switch is closed and electrons are now being removed from the right plate of the capacitor through the battery to gathering on the left plate of the capacitor. You'll notice that the voltmeter of the capacitor is increasing in potential, meaning that charge is separated. We're now going to charge the capacitor. We have a battery, a switch, the capacitor, and an ammeter all in series. When the switch is closed, the battery will put charge on the capacitor in a very rapid fashion. The ammeter is reading a very high value as charge rapidly goes on the capacitor. As the capacitor becomes charged, it's more difficult to put charge on the capacitor, and the rate will slow, and the ammeter indicates zero flow at the end. Now that the capacitor is charged, you'll note extra electrons on the left plate and extra protons on the right plate. The switch will be closed and charge will flow off the left plate very rapidly, resulting in a bright initial glow from the bulb, and as the charge movement slows down going to the right plate, the current across the bulb will decrease and the bulb will go out. Here is the discharge of the capacitor through the bulb. Whenever you're ready. As you can see from our data, we have an exponential discharge of the voltage across the capacitor. Here's the equation for that. The voltage across the capacitor is equal to the original voltage, which is going to be our 1.5 volt battery, times e to the minus, that's literally time, divided by the product of the resistance times the capacitance, and that's known as the time constant. Now here's a sample calculation for the voltage discharge across the capacitor. The voltage discharge across the capacitor is equal to the original voltage. We use the 1.5 volt battery times e to the minus. We arbitrarily chose a time of 5 seconds, so we'll put 5 seconds here, divided by our time constant, which is the product of the resistance times the capacitance. The resistance we estimated to be around 30 ohms, and the capacitance of our capacitor was approximately 0.1 farads. Actually doing the math here, it turns out that after 5 seconds, the voltage across the capacitor should be 0.283 volts.
Let's switch out our capacitor with a Leyden jar. But before we do, let's show you how to make one. To make a Leyden jar, you're going to need a couple of things. You're going to need 2 cups, some tin foil, and a straw. First, you'll need to take out a cup and completely wrap the outside of the cup with foil. Be sure any excess at the bottom is cut. Next, secure the aluminum foil with tape. Make a second cup the same way. Next, wrap a straw in a small amount of tin foil. Tape the straw to one of the cups. Take the cup and put it inside the other cup, making sure that the cup with the straw is on the inside. Finally, press both cups tightly together. Now you've just made a Leyden jar.
Now that we've made one, let's charge it up. By holding a jar by the straw close to a Van der Graaf generator, you can see the sparks charging it up. But how does it work? In this diagram, we can see a very negative Van der Graaf generator. When you get close to it with the Leyden jar, the charges jump from the generator surface to the outer cup. At the same time, some of the negative charges of the inner cup will leave through you to the ground, making it positively charged. Keep in mind that the charges can't get through the plastic cups themselves, so they don't mix. You discharge the Leyden jar the same way as the capacitor. However, with the jar, there is a huge amount of charge moving through the circuit at once, so you get a very bright flash. Let's see this in action. When you close the switch, the bulb will flash just like a camera. In fact, there's so much charge going through it at once, the filament will break.